Hello, YouTube learners, students, and colleagues. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. This is a specialized lecture. I want to show how to do computations for a spherical cap using sequential control structure. And this is also test one review for my CS1 class. So let's dig in. Basically, a spherical segment is a spherical cap with truncated top. So if I take this sphere and cut off a plane here so that line from center of the sphere going perpendicular to this plane, and this surface and this surface are parallel. So this surface is the radius of B and this surface is the radius of A, and height of cap is H. So when you take it out, it'll look like a little spherical stool, and it's also called frustum of a sphere. So there are geometrical formulas available for the surface area, total surface area, volume, and also the radius from which this cap has been cut off. So our goal is to get the formula for volume, surface area, and radius of the sphere from which this has been cut off, the math form of those formula, convert them into C++ form, and also compute how much it will cost to paint all the surfaces given certain cost per unit. So if you dig into math, these are the formulas in the math form for volume, total surface area, and radius of the sphere from which the cap has been derived. The square root is only for the numerator. Denominator is just 2h out of the square. Okay, so as has been our technology that I developed called IOA, we'll do IOA for this program. First input table, output table. Maybe we are using some intermediate variables and constants, their details, and then conversion of math formula, you see 3 of those, into C++ form, and maybe there's a good way for us to compute pi, which we're going to be using here, and then converting raw cost to whole dollars and cents. Okay, so let's keep going. So program will ask user only for A, B, and H, and find the volume of actually we should see and total surface area and print them to 4 decimal places. In the expression R here, the numerator is the only one that is under square root, not the denominator. Imagine the program also asks to compute the cost of painting all surfaces of cap, such that cost of painting is 0.02 cents per unit area. Then program also outputs the cost of painting as whole dollars and cents. Okay, so it's pretty clear that user is going to input B, which is the radius of the top circle, and A, which is the radius of the bottom circle. Obviously A is greater than B. We won't be testing for that because we are still waiting to learn about if and else. and height of the cap. So those are the three inputs. And outputs would be volume, surface area, radius, and dollars and cents. That is cost of painting. So let's look at what our input variable names in table is. There's B, so double type because geometrical shapes are not necessarily in round numbers always. And that's the radius of the top surface of the cap. And the A, again double type, radius of the bottom surface of the cap. H, again double type, that's the height of the cap. And once again, height, B and A. Okay. All right. So then output requires volume, surface area, radius. Those will be all double type because once again, you cannot force geometrical properties to be in round numbers. And when we paint all the surfaces and compute cost in dollars and cents, well, whole dollar will be int and whole cents will be int. We're going to be using some intermediate variable and constants, and this table is not monolithic in the sense that each person could be doing it in a different way. So correspondingly, their number of variables might be different. Some might do in a way that you don't really even need anything other than the two constants that we have here. But in any case, as you know, the named constants are usually in uppercase letter. So we have pi, which is value of pi, obviously double type. COST in uppercase will be cost to paint per unit area, which we set 0.02 cents in this case, and we'll show how to declare that. Raw cost will be basically raw cost of painting, and so that'll be this multiplied by that. And okay, I just realized it's already in pennies, so there's a bug in my code. I'm going to fix that in a minute. And then you have total pennies, which is 100 into raw cost. Actually, in this case, it won't be 100 because we already have 0.02 cents per unit area, but this one is correct. Okay, so total penny is actually in the raw cost. So actually we could, if we like, yeah, you could skip one variable in this case. So I'm going to take this off, actually, delete. We don't need it. Okay. All right. So first, let's see conversion of geometrical math formula to C++ form. One is that in C++ you could compute pi exactly by using a C++ math function called arc10. And it just happens to be 4 into arc10 of 1. Arc10 is called A10 in CMath library. So C++ form of this will be const double pi equal to 4 A10 1.0. Okay, we're going to use that in the source code in a minute. And as I said here, C++ math library arc10 is actually A10, and you need to include CMath. It's interesting here how we convert this into C++ form. As I have mentioned many times, you don't want to use POW function to do square, just multiply A by itself. Crucial thing is these two, 1 by 6. 1 by 6 is 0 in C++. You have to understand that. They're both integer division. Integer division truncates, gives you quotient only, truncates the remainder. when denominator is larger than numerator, you only have remainder and that gets truncated. So in C++ form, we cannot write 1 by 6. Rather, we write 1.0 divided by 6. That does the automatic conversion, and this gives you the floating point division. Rest is pretty easy. Pi, there is no pi symbol on the keyboard, so we can't use that, and we just defined pi here as a constant, so we'll use that. And then into h, and in the bracket we'll have these three things: 3 into a, 3 into b plus h into h. Notice that you do need this asterisk here because parentheses alone do not do multiplication in C++. So you need that asterisk. More amplification here. 1 by 6 in C++ is 0, so we avoid that by rewriting that as 1.0 divided by 6. Other option will be casting the numerator into double form like this, but that's an overkill. We don't need that. This is good enough. And here we're taking square root of this whole thing. And understand there are no square brackets in source code in C++ form. In fact, we cannot use anything other than parentheses. So obviously there will be one parenthesis for the function call, the red one. Black one will be for this square bracket, this one, which, okay, this matches with this guy over here. And then we have brackets for a minus b square, so which is this one, a minus b into a minus b. And okay, let's see here. And understand that h square has to be added to this before it gets multiplied by this other one, a plus b square plus h square. So, okay, so I was wrong earlier. This matches with that. Okay, yeah, that was a mistake I made. So I say a minus b into a minus b plus h into h. So we did this part. And then this whole thing gets multiplied by this quantity here. So that's simply parenthesis, parenthesis, and a plus b into a plus b plus h into h. This whole thing is under SQRT. To enforce order of operation, we need to divide by 2 into h. Okay. Surface area is pretty straightforward, but you can see the pi is common in all three terms. So I took that common out. And then we have 2 into r into h. So we have that. And then since I took pi out, I have a square, so that's a into a. And then I have b squared, that's b into b. Okay. Now, once I found cost in rounded pennies, this one, okay, I should say in pennies. And I rounded it by adding 0.5, casting to int. Then my dollars give me, are given by rounded penny divided by 100, and cents are given rounded penny modulus with 100. And now I want to show you the source code and execute it. That's better done in Xcode. So let's go to Xcode. That's the Xcode here. Let me make it a little better for you. And this, don't worry, this will be copied and pasted into the document that I'm going to be uploading. But let's just look at the code here. So Actually, once again, let me fix it because there were some bugs in there, and this 100 multiplication is not needed because it's already in pennies. Okay, so let's see, maybe I will do it in the Word document itself because fonts are bigger, and then I'll come back here to run it. So the way we're going to convert based on the input output and analysis, and you should practice writing algorithm for this yourself. This is how we can do it. IOStream, IOManip. In case I want to format, in fact I do format the area, volume, radius to 4 decimal point, and then CMath for square root. And then I have two constants. One is pi, which is 4 into arc10 of 1.0. This function is CMath. And did I say 0.02? Let's put 0.02 here. I'll go and check my source code. Was it 0.02 there? Yeah, it was. Okay. So why do we do this? Because I want to avoid scientific output. For that I use fixed. If a floating point number is a whole number, I want to use show point 0 or 0.000, whatever for that. For that I use show point. And then I want to show 5 decimal points in the mantissa. For that I use set precision. Mantissa is the decimal parts. So it says this program will compute volume and surface area of the spherical segment. Value of pi used as the full accuracy, but shown to 5 decimal point. And it is, I just go ahead and output it. When this line is executed, computer will actually compute this and store into this one. I have done multiple declaration here on the same line, but this style is not accepted in labs. In test it's okay, you could do that, but we do not accept that in the labs. Okay, and then basically B, A, and H have to be inputted. So I ask radius of the circle on the top of the spherical segment, then I ask at the bottom. Once we learn if and else, we could test that this is larger than that, otherwise it will not be spherical segment. And then we ask for the height. After that, 3 computations for volume, radius, and surface area are pretty straightforward. They're exactly what we had here, here, and here. And if you do this in a text document, you can copy and paste that into source code, but not from Microsoft Word. Okay. So I guess I'm not showing the cost computation. I will in a minute. So I print the radius, volume, and surface area. I have the raw cost here. Let me copy and paste for you in this document the dollars and cents computation. That's right here. Okay. Okay. Destination format. So raw cost will be S, which is the surface area that we determine here, into cost, which is 0.02 cents per unit area. So I don't need to multiply that by 100. This is already in pennies. So total penny is the raw cost, and I could have avoided one variable here because it's already in pennies. But then to round fractional penny into 1 or drop it off, I've shown this procedure several times. I add 0.5 and cast it to int. Once this is integer, I can do division by 100 to get the whole dollars, modulus with 100 to get the whole cents. And then I print dollars and cents. Okay, so what I'm going to do now, in Xcode, I'm just going to run this program, and I've done some modification here now. Yeah. And I'm just going to use some values like, what did I use? 2, 5, and 1 for one case. So let's run it. And this you may or may not be able to see in video, but document will have it. So 2.0, 0, 1.0. So this one is $0.03 is the cost. So we'll add that to our document here. And second one was 5, 16, and 7. So let's run it again. 5.0, 16.0, I think it was 7.0. Yeah. This time we got this one. The cost per unit has been kind of arbitrary. Certainly we can play with those numbers, but I don't know what happened. Why didn't it do it? Okay, it's right here. Match destination format. Somehow it's not doing it. I will fix that. In this document it will have it. It's not a problem. So these are the steps. You read the problem statements, you build your input table, output table, intermediate variable if there are any, and convert math formula to C++ form, and have formula for how you're going to get dollars and cents from rounded pennies, have all the includes, have all the constants if there are any, set formatting flag for the floating point numbers, and variable you can declare any way you like. Some people find it comfortable to declare them at the top, which can be done for a while anyway. And then you take input, you apply the formula to compute all the outputs, you output all the computations it did, you get the raw cost. In this case, cost was in pennies, so I don't need to convert that into total pennies by multiply by 100. In this case happens to be the raw cost and total pennies are same. I create extra variable. I didn't have to change it. Rounded pennies by 100 becomes dollars, modulus with 100 becomes cents, and I output those. Okay, so that's my video test one review, and I will upload this document also to the canvas. So right now, this is Dr. Satish Singhal, PhD, saying goodbye from this test one review or spherical cap computation. Thank you.